Hi everyone, my name is Dawn Simone. I'm in Miss Davis's Chem 151 class, and I would like to present to you a limited reaction percentage yield equation. If you want to follow along in the book, it's 3.91 on page 116. So I've written for you on paper the question and then our equations that we're going to use. We have nitroglycerin, which is C3H5N3O9. It is a powerful explosive. Its decomposition is represented by the equation 4C3H5N3O9 yields 6N2, 12CO2, 10H2O plus O2. This reactant generates a large amount of heat and gaseous products, and it is the sudden formation of these gases together with their rapid expansion that produces the explosion. In part A of the problem, we're trying to determine what is the maximum amount of O2 in grams that can be obtained from a 2.00 times 10 to the second gram of nitroglycerin. So we'll start with that one. Just do the top part. The equation again is 4C3H5N3O9, yielding 6N2, 12CO2, 10H2O plus O2. So in the equation we have 4 moles of nitroglycerin producing 1 mole of oxygen, and we're going to use that in our equation. We take the amount, 2.00 times 10 to the second grams of nitroglycerin, times 1 mole of nitroglycerin, which is equal to 227.10 gram of nitroglycerin. You can get that by determining how many grams are in each atom that we have in our equation of each property. So you take like your carbon and multiply that gram times 3. Same with hydrogen, nitrogen, and oxygen. We're also going to multiply that by 1 mole of O2 divided by 4 moles of nitroglycerin, because our equation says that 4 moles of nitroglycerin produce 1 mole of oxygen, O2. Then we're going to multiply that by 32 grams of O2, because we have 2 grams of oxygen, or 2 molecules of oxygen, which are 16 grams each, so that gives you 32 grams, divided by 1 mole of O2. Now, what we're going to do is we're going to first cross out the things that are duplicate here. So we've got our grams of nitrogen, canceling out grams of nitrogen. We've got moles of nitrogen, canceling out, on this part of the equation, moles of nitrogen. We have moles of O2, canceling out moles of O2. And what we're going to be left with is grams of O2, which is what we're looking for. So if you multiply across the top, I like to do top first and then bottom and then divide at the end. It just helps keep it a little straight for me. You can do the equation however you like on the calculator. So we've multiplied our 2.00 times 10 to the second times 1 times 1 times 32, and that's where I get the 6,400. And then the bottom part of our equation is 227.10 times 4 times 1, which gives you 908.4. And when you divide 6,400 by 908.4, it gives you 7.05 grams of O2. And that is how many grams of oxygen we get out of that equation. Now for part 2 of the question, we need to calculate the percentage yield in this reaction if the amount of O2 generated is found to be 6.55 grams. So for that portion, we're going to do percentage yield is equal to actual yield divided by theoretical yield times 100%. Our actual yield in this part was 6.55 grams because that's what they told us. According to our first equation, the theoretical yield according to the actual equation should be 7.05 grams of oxygen. And then we multiply the whole thing by 100% to give us our actual percentage. So if you divide 6.55 times 7.05 and multiply that by 100, it gives you 92.9% yield. And that would be your percentage yield of oxygen according to an experiment that yielded 6.55 instead of 7.04. I hope that sheds a little bit of light on limiting reactions and percentage yields, and I hope everyone does well on the exam.